Hello class, welcome back. It looks like I'm drowning in a sea of beige today. I've got a beige shirt and walls and sofa behind me, but I'm doing all right. Hope you guys are doing all right as well. And today we're going to talk about how important it is to include multiple variables in a regression when we are trying to make sense of how one thing, an x variable, is affecting y, the outcome variable. So we talked about regression with just one x and one y, and last lecture I talked about how we can actually include multiple x variables in there. We can stack a whole bunch of x's and see how each of them affects y. And the important part of doing that, why it's so powerful, is because we're now controlling for all of those different variables, things that we have reason to believe might be important in affecting this outcome. So, for example, in the slides we have a regression of alcohol use on a whole bunch of different explanatory variables, and specifically we're looking at alcohol use in relation to work. So this data set comes from a survey that asked people a bunch of questions about whether they drink alcohol, how much, and questions about their work, and questions about the interaction between the two of them. So like most regression results, we'll see that the outcome variable is listed at the top of the column. And so the first column that we'll focus on is about drinking just before you go to work. So if you're looking at the same table as me, you'll see just before work at the top of the first column, the column that has numbers below it. Before that, we see going down in the rows, the different explanatory variables that were included in this regression. Those are all the different x's. So we have gender, race, age, education, family income, hours worked per week, weekend work, seasonal work, and then two variables for supervisor, social control, contact, direct contact with your supervisor, and enforcement. Does your supervisor have direct ability to enforce the company policy on alcohol? So if we look at the first column, we are trying to explain or predict who drinks right before going into work. So that's the outcome we're looking at. So this is actually an outcome that takes the form of a 1 if the person has, within the past 7 days or month, I forget what exactly the survey was asking, within the past period of time, they have gone into work after drinking some alcohol, or put it differently, they drank some alcohol before going into work at least once. That's what we're trying to explain. So the people who said, yes, I've done that, they would be coded as a 1. The people who say, no, I haven't done that in the last month, got coded as a 0. If we look down, we see a variable like gender. So this is specifically a coefficient on male. It has a coefficient of 0.73, and we see no stars next to it. Now what that means is that in this regression, male does not seem to play a big role in explaining what's going on. With no stars next to it, that means it's not statistically significant. In this regression, we can't say with confidence that that number, the 0.73, is any different from 0. So in effect, we're going to treat it like 0. We're going to say, gender doesn't seem to play a big role in explaining who drinks before going to work. Same thing with race. We see there's no star next to that number. Age, education, family income. When we get down to work hours per week, we see a negative coefficient that has a star next to it. So now we're talking about a result that is statistically significant. That's what we're going to call it when it has at least 1 star next to it. And it has a negative coefficient, so that means people who work more work hours are less likely to have had alcohol before going into work. So people who are working long hours are less likely to be drinking before going into work. The next variable is weekend work, and with that one we see a number 2.31 and it has 3 stars next to it. So that is statistically significant. We're going to say if it has stars, it's significant. We're going to count it. So that's a positive coefficient. There's no negative sign in front of that 2.31. So what it means is people who work on the weekend are more likely to have responded, yes, I had alcohol before going into work. Personally, this seems to make sense to me. I'm not surprised by this result. If I think about people who work on the weekends, you may go to a birthday party or a tailgate or something and have a beer, go work your shift after that. Well, that means you would answer yes to this sort of question. It's more likely to have a situation like that where there's some amount of day drinking of alcohol on the weekend than on the week. So we see a positive coefficient. Now, I don't know that's what's going on. All the numbers say is that there is this conditional correlation between weekend work and drinking before you go in. So that's what this regression is showing us. It's showing that there is a strong relationship, and it's a positive one, between working on the weekend and drinking before you go into work. We'll talk later about how we have to be careful about how we interpret these coefficients and what we make of them. If we go down, the next significant coefficient that we see is for enforcement. If you have a supervisor who is directly able to enforce a company policy, they have authority to fire you if you show up with alcohol in your breath. That makes you less likely to have had alcohol before coming into work. So if we look, we see those are the 3 coefficients in that regression that have stars next to them. Those are the statistically significant ones, and all of the others are insignificant, or we would not statistically significant. We will treat them as 0 basically. Now, this is such a powerful tool because what it's doing is it's saying there are all these different things that may help us understand what's going on with people drinking alcohol before going into work. These are the ones that the numbers say matter. All the other ones we're setting aside. So we're setting aside differences between male and female. We've controlled for that. We've included it in the regression. It doesn't, in this regression, play a role in explaining what's going on. It's not statistically significant, but we've still controlled for it. So that's not what's going on. We've controlled for it. We've controlled for race and age and education and income. We've controlled for a lot of different features that we may think would be important at trying to explain who's drinking alcohol before going into work. And this regression allows us to basically focus on the variables that have the most explanatory power. And we see whether they're positive or negative. The number of stars is an indication of how confident we are in those results. How sure are we that they're not 0? And so more stars means we have more confidence in them. Now, if we look at the second column, it's drinking during the workday. So that's a different y variable, a different outcome that we're looking at now. We have the same set of x variables, but now we're running a different regression with a different y variable. So that's important to keep in mind. You can have as many x variables as you want in a regression, essentially. That's not totally true. As a stats professor, I should perhaps walk that back. You definitely want more people in your sample than you have number of explanatory variables. But you can have a lot of x variables, especially if you have a big data set to work with. You can only have one y variable for these sort of regressions. And so each column we're seeing in a table like this is a different regression that's been run. So the second column is who drank during the workday. Here we see the first variable, x variable, male has a positive statistically significant coefficient. So that's telling us males were more likely to respond that they had something to drink during the workday than females were. We see age has a negative coefficient with a star next to it. So older people were less likely to respond that they had alcohol during the workday. The flip side of that is younger people would be more likely, right? If older people are less likely, it means young people are more likely. Those with a lot of education, higher levels of education, were more likely to say they had something to drink during the workday. People from higher, people with higher family income were more likely to say they drank during the workday. So there may be a bit of Mad Men sort of thing going on here, right? We have younger people with high education and high income levels drinking at work or during the workday. It's not necessarily at work. It could be that you have a martini lunch or something along those lines. But it does look more like a martini crowd than a beer crowd with that positive coefficient on family income. The other significant coefficient we see is a negative coefficient in front of enforcement. So again, if you have a supervisor who can fire you on the spot, if you smell like alcohol, you're less likely to take that martini lunch, which would make sense to me. It fits with my priors. If I do kind of a gut check on it, I say, okay, I'm not too surprised to see that result. Again, not saying that that's right or wrong. It's just a way to think about these things as you go through these results. So what we've done in this video is we have looked at results from multivariate regressions, where we have a bunch of x variables. We focus on the ones that the numbers say matter, that have a strong conditional correlation with our outcome variable, the ones that are statistically significant, the ones that have stars next to them. And I've really focused on whether it's a positive or negative coefficient. I haven't focused on the magnitudes of the coefficients. We'll get into interpreting them a little more later once we get into prediction. But the other thing that we've done in this talk is we've talked about how important it is to have important variables in there, in that set of x variables, because what we include in the regression we control for. We can kind of set that aside. People come back and say, yeah, well, it's only showing that for wealthy people because wealthy people work more hours per week or something like that. We could say, no, actually we control for the number of hours you work per week. That's one of our x variables. And that one in the second regression was not statistically significant. So we are focusing better on the things that we're most interested in, trying to explain what's going on with our y variable. I know this stuff gets complicated. It's really powerful, and that's why it's really important. Our book doesn't do a good job covering that, and that's why this week we are spending some time going through regression results, figuring out how to interpret them, and next step will be how to use them. How do we use these multivariate regressions to make something like a prediction model, which is basically what Amazon and Netflix and Google and all of these tech companies do to figure out what you might want to do next so they can target things to you, whether that's ads or recommending the next video to watch. I'll recommend watching the next video in this lecture series. So there we go. I'll talk to you guys soon.